have time to get it all done. All right, we're working on a 5-1 review. It's on page 39. And so the first thing is, what is the definition of bisect? And we also want to talk about perpendicular bisectors down here. So the definition of a bisect is basically, this is an unofficial definition. It's, a bisector, something to bisect, splits object into two equal parts. You have two equal sections, bisect sections. Splits object into two equal parts. And I don't know what the object is specifically, but it could be most likely a segment that we're splitting in half. Okay, so we have some examples of perpendicular bisectors. Perpendicular means it's going to make a 90-degree angle, and then you've got your bisector, which splits it in half. So a perpendicular bisector does not have to go from vertex to opposite side. The only reason that's happening is because this is an isosceles triangle. So that's the ticket. This goes from here to here. It makes a 90-degree angle, and they told us this is congruent. Guys, this goes back to our congruent triangles. Remember SAS, side, angle, side? These triangles are congruent because of this angle bisector, creating these two 90-degree angles. So then CPCTC, if you have congruent triangles by side, angle, side, then all the corresponding parts are congruent for the triangles. Corresponding parts of congruent triangles are congruent. So that means that if this is 16, that's 16. It's not a guess. It's not because it looks that way. We can prove it. All right. So I will let you take a quick second to look at number 2. Maybe we will do this together. We'll see. Now they're telling you it's an isosceles triangle. So if that's 4, that's 4. Not only is it an isosceles triangle, we have a perpendicular bisector. That means that these are congruent. So what is AB? Well, 2.5 and 2.5 is 5 units. I guess I'll write units on the other one because it's units there. Okay, now we're going to step it up a little bit. Look at number 3. We again have that perpendicular bisector, 90 degrees, 90 degrees. If these pieces are congruent, that's that reflexive. We have congruent triangles by side, angle, side. And so all the corresponding parts of the congruent triangles are congruent. That means that this segment is equal to this segment. But I have some algebra to do. So to find x, I need to do that to find the length of AG, or HG. Just making stuff up. This equals 5x minus 3. So I'm going to move on, but you're going to take the time, you're going to solve that, and then find HJ. Okay, now this is on a different page. Don't ignore me because you're going to have time to come back and do some of this on your own. We also discussed angle bisectors. An angle bisector splits an angle into two congruent angles. So if I have this angle, and I create this bisector, that means that this piece is equal to that piece. So an angle bisector is something that splits an angle into two congruent angles. It's typically a ray. All right, so go ahead, flip it over, and let's see what we have. Again, you'll come back and solve any of these missing ones. Okay, so looking at this, there's a lot going on. We're going to solve for x. Here's what I see. This side is congruent to this side because they're both marked 74. This is reflexive, isn't it? Now, we know we can't use that angle side. That was not one of them. But this is that hypotenuse leg, guys. Do you see the right triangle with the 90 degrees? And do you see the other right triangle? We have a congruent hypotenuse for both of them. We have a congruent leg. Because it's a right triangle, we have that hypotenuse leg. So these are congruent triangles, so we have that CPCTC again. Now, if you think about this, if these triangles are congruent, then this angle is congruent to this angle. This ray, BD, must be an angle bisector. So 2x plus 8 must equal 4x minus 2. All right, so you're going to take a minute, you're going to solve that for x. But again, I'm going to have you do that when you get to work. I want to move through this. So number 7, very similar idea. We have a lot of pieces to find here, and make sure you're finding angle measures. Here's what I know again. We have a 90-degree angle. They've marked this angle congruent, and this side is congruent. Guys, this is angle, angle, side. Angle, angle, side tells me these triangles are all congruent. So then by CPCTC, this is congruent to this. Now, in order to find this angle, I need to find x. So to find x, since I know these are congruent, 7x, do you agree it says 7x minus 13 equals 5x minus 3? Once I find x, that opens up all the doors. Pay attention to your angles. GDF is this little guy, okay? FDE is this guy, which would be congruent to it. Okay, jump on down. So you're going to come back and finish these up. Now, we are using this picture for a lot of things, so we have to be careful that we don't mix things up. It says, given that FG right here is congruent or is equal to HG, and angle FEH. So we're going to have to watch because we're going to be doing different labels on this. Angle FEH, this whole angle is 55 degrees. Find the measure of angle GEH. Okay, now, I can't just assume these are congruent, but this is that hypotenuse leg again. I have a 90-degree triangle. I have a hypotenuse and a leg that matches here. So corresponding parts of congruent triangles are congruent. So picture this triangle. This little angle is equal to this little angle. Okay? So with that in mind, the whole thing is 55. So what is GEH? It's half of it. GEH is 55 divided by 2. So is that 27.5? Anybody agree with me? Okay, good. Someone agrees with me. Now, given that EG bisects the angle, okay, same idea, FEH, so it cuts this angle in half, and it says GF is the square root of 2. What's GH? Well, that's not hard. Hey, if this is the square root of 2, what's GH? It's also the square root of 2. Done. All right, go ahead and look at the next part. Given that angle FEG is congruent to angle, okay, FEG is right here, GEH is right here. All right, since these angles are congruent, now they're telling us to find this. Okay, all of this comes back to here they're telling us the segments are congruent, so we knew the angles were congruent. Here they're telling us the angles are congruent, so we'd have angle, angle side. So this one is angle, angle side. So we have different reasons they're congruent. And then it says FG is 10z minus 30. HG, this little one, is 7z plus 6. Guys, all you have to do is set them equal to each other. So you're reusing this figure for different problems. I'm going to run out of room. Okay, so go ahead, take a minute and solve that. We'll just finish this problem together. So take a minute and solve it. All right, let's see if we agree. I'm going to subtract the 7z. Oh, I'm really struggling, guys. All right, so 3z minus 30 equals 6. I'm going to add 30. And 3z equals 36. So I'm going to say z is 12. Do you agree? Okay, now that's not what they asked for. If z is 12, they want fg. So fg would be 10 times 12 minus 30. Well, that's 120 minus 30, so I'm getting it as 90. Anybody agree with me? Okay, it's 90 units. This was the square root of 2 units, and this was degrees. Okay, last one. If these segments are congruent, then we know these angles are congruent. So they're telling us angle GEF. GEF over here, they're telling us that is 8/3 A. Oh, this is getting messy. And then angle GEH is 24. Okay, well, then I know that I would set these equal to each other. That's all I'm doing. 8/3 A equals 24. Now, typically we would divide to cancel that out. And you can put that in your calculator. Oh, this is a mess. I hope you guys are doing better than me. I'm going to do this down here. 8/3 A equals 24. Now, I don't like to divide by fractions because I don't have a calculator that I'm using. So I'm going to multiply by the reciprocal. And so this is going to cancel. And 3 goes into 3 once, and it goes into 24 8 times. So what is A? That can't be 6/3. I didn't flip it. No one wants to tell me that? I was talking about the reciprocal. Come on, guys. No one wants to yell at me? So this would be 3/8. See, I wrote it here. I didn't write it there. Okay, 8 goes into 24 3 times, so A is 9. I knew I was wrong because there's no way if I had 64, I would get that 24 back. So A is 9. I'm going to have to do better. Okay, so this was my work for number 8. Right here. And this was what we did for number 9, which is a little bit messy. Okay, I'm hoping you guys were neater than me. Not my best start. All right, looking at these. Determine if the indicated segment is an altitude, median, or perpendicular bisector. And then we need to think about it. How is an altitude different than a perpendicular bisector? Okay, what's an altitude? Well, an altitude is the height of something, right? The altitude goes from the vertex to the opposite side. But an angle bisector does not. So, for a perpendicular bisector. So altitude, oh boy. Maybe you should do this, Mr. Adams. Altitude goes from vertex to opposite side, meeting, I'm doing MTG for meeting at 90-degree angle or right angle. That's what your altitude does. An altitude does not split it in half. An altitude doesn't split it in half, and it has to go from the vertex to the opposite side. A perpendicular bisector, I'm going to abbreviate that. Perpendicular bisector does not have to go from vertex. Or does not have to come from vertex. How about that? Does not have to come from vertex. It is a segment that creates 90-degree angle and bisects side. So let me give you an example. I'll do 2 different ones. This line is an altitude, okay? Because it goes from vertex to 90-degree angle, and that's all we know, 90 degrees. If I have a triangle that looks like this, this is a perpendicular bisector because it splits it in half. So that is a perpendicular bisector. All right, that's the big difference. Okay, so how is a median different than an angle bisector? Well, a median cuts a line in half, and an angle bisector cuts an angle in half. So median goes from opposite vertex to midpoint of side. So we're splitting a segment in half. An angle bisector it starts at the vertex, but an angle bisector is often a ray that splits angle in half. So you have two congruent angle. So I know those aren't the most official, but it would be a lot of writing, so I try to sort of put it in our words. So we focused on altitude, angle bisector, median, angle bisector. Okay, so I think that you should be able to do these. Now, listen, you're trying to decide, the words are up here. I'm going to transfer them down here. Is it an altitude? So I'm transferring the words up here down to here. Do you have an altitude? Do you have a median? Perpendicular bisector? Angle bisector? You don't have to transfer the words unless you want to, or none. But I can't see the words when I move this up. So that's all I did was I just transferred what was up there. Okay, so if I look AB, AB is right here, trace it. Doesn't that form a 90-degree angle with the other side? So AB is considered an altitude. That's what you're doing. Let's look real quick at number 11, because that's an oddball one. AC. I see a 90 degrees, but guys, it's not an altitude because altitudes have to go from from vertex to opposite side. This just randomly does this, but not only does it make 90 degrees, do you notice the congruent segments? This one is a perpendicular bisector. All right, so I will leave you to decide what the rest of these are, and that is it. The back is blank, okay? So go ahead and finish up those couple problems that we did not finish. So you will be finishing what? Number 3, number 6, 7, and then these back problems.